Hi. Now I want to talk about the bonding and in some details. Maybe this presentation by PowerPoint will be like some a new understanding or just to approve the understanding. So a review of chemical reactivity. The octet rule, atoms tend to gain, lose, or share electrons to try and have 8 electrons in their outer shell. Noble gases are non-reactive because they have 8 valence electrons. Ionic bonding, it's all about ionic. So bonding by gaining or losing electrons to achieve full outer shell. So it's a matter of gain or lose. And then what's the result will be a full out shell for more stability. Valence electrons in the outer shell the most shell. So we use these to help with bonding. So where are the electrons? They are at the outer shell. What are they responsible for bonding? Definitions: ion, charged atom. The ion is a charged atom. Atom that gain or lose lost electron and has a positive or negative charge. So once the ion like gained electron, it means increase the electrons. We call it an ion, and then increase the minus charge. If lose the electrons, so they became cations and they will become positive charged. So a cation is a positive charged ion. An ion is a negative charge. So in chemistry, it's not like in real life. In real life, when you gain something, you will be positive. If you lose something, you will be negative. But in chemistry, related to the atom, once the atom lost electrons, become positive charged or cation. And if the atom gained electron, it will become negative charged anion. So ions, an ion is an atom gained, as I said, or lost one or more electrons and has a positive or negative charge. And atom gains or lose in why atoms gains and lose electrons in order to achieve octet rule. Like these are the small atoms or low, we call them, they are low atomic numbers, and they want to achieve 8 valence electrons in the outer shell. So when you see positive, the atom is losing an electron. When you see negative, minus, atom gained electrons. Metallic characters, here, if you see in yellow, these are metals in the periodic table, all of them. To the left, in the middle, down, these are in yellow metals. In the green, non-metals. In the purple will be metalloid. In between, their properties, physical, chemical properties between metals and non-metals. Metal elements, nearly all metals form cations. This is not cations, these are cations. Magnesium has 2 valence electrons. in the outer shell. So it's much easier to lose these 2 electrons than gain 6 electrons. So magnesium atomic number is what? It's 12, I think. 1s2, 2s2, 2p6, 3s2. So losing 2 electrons better than gain 6 electrons from the final or shell. So magnesium, when lose 2 electrons, becomes magnesium 2 plus. It's better to write it 2 plus, not plus 2. Or you can use magnesium plus plus. So it's a cation. Non-metal elements, nearly all non-metal elements form anions. So these are anions, non-metals. What they want to gain electrons. So oxygen has 6 valence electrons. Easy to gain 2 electrons to become 8. So they have 6 at the outer shell. Just need 2 electrons to be fully occupied, valence electrons or shells. So it's better to gain 2 electrons rather than losing 6. So oxygen will be O minus, sorry, 2 minus, and we call it anion. Ion names. How can we name the ion? So naming cation, positive ions that lost electrons, simply name the element and then you can add, it's the same name of the element and you can add ion. So when you see example of Na plus, it means sodium ion. Magnesium 2 plus, magnesium ion. Ion names, if gaining electrons, we call it anion. So the element name ends with "ite." So Cl minus, it's chloride ion. O2 minus will be oxide ion. Ionic bonding, force of attraction, the ionic bonding, it's a force of attraction between positive charged and negative charged to create the ionic bond. So there will be attraction between the positive and negative. These are attractions done by what? By the cation anions. So these are ionic bonding. Example, wants to be neutral, sodium ion, Na plus, has +1 charge. Chloride ion, Cl minus 1, has minus charge. So sodium chloride is the table salt that became or formed from the attraction between plus and minus, between sodium and chlorine or chloride ion. Ionic bond, electrons lost or gained resulting formation of ions in ionic compounds. So let's check this. You have potassium, 1 electron. In the outer shell, there is 1 electron for potassium. In the outer shell of fluorine, we have 7 electrons. So what will happen? This electron will go, because of the fluorine high electronegative, so it will pull this electron to be on its side. So the potassium will lose this electron to the fluorine, but they will form a, see? Now, the 2 electrons, now this strange pinky electron came from the potassium, and then with the 7 electrons of the fluorine, so it's 8 electrons. So this is the A octet rule, we call it octet rule. So the fluorine form bond with potassium and to fill the outer shell. Okay. So now potassium lost electron +1. Fluorine gained electron -1. Ionic compounds names cation goes first and then anion. So remember, when naming an ion atom gains electron, it will end with "ite." The one gained electron, we just change it to "ite." So now you have sodium NaCl, so it will be first we name the sodium and then the chlor. So sodium as it is, but the chlor becomes chloride, sodium chloride, sodium chloride. MgO, magnesium oxide. Now let's come to the compound potassium fluoride. Consists of potassium K plus ions or cations and fluorine fluoride F minus and ions. And you can see ionic bond is the attraction between the positive K plus ion and negative minus F ion. Now that's for the ionic bonding. Let's come to the covalent bonds. What are the covalent? Sharing means. So bonding, sharing electrons to achieve full outer shell. In all cases, we have to share electrons. Either both of them go to one atom, this is ionic, or both of them stay in their outer shell, but they share the two electrons equally. So it's a covalent. So now covalent bonding atoms still wants to achieve a noble gas configuration or octet rule. But rather than losing or gaining electrons, atoms now share this pair of electrons. The shared electron pair is called bonding pair. Okay, so there is ionic electrons, but here we have a sharing electrons, which is a bonding pair. So now we come to the chlorine gas, forms covalent bond with itself, Cl2. How? How will two chloride atoms react? Let's see. So everyone is equal in electronegativity. Nobody is more powerful than the other one. They are similar. They're homodinuclear. And then let's see what will happen. So now neither each chlorine atom wants to gain one electron to achieve octet rule, but neither atom will give up an electron. So what's the solution to achieve the octet rule? They came close together. Let's see. Aha, they come close together. So now they came closer. You remember the ionic bond, the two electrons came beside the more electronegative atom, and the other one kept a distance. They form a single bond, but like that one lost, the other one gained. Here, they sharing, so the bond will become together shared. So this chlor achieved octet and the other one achieved octet. So both of them, they achieved octet rule, 8 electrons, but by sharing. So the octet is achieved by each atom sharing the electron pair in the middle. And that's it. This is how they combine together, or we call it overlapped. And these are the sharing of 2 electrons. This is a covalent in the middle. So this is the bonding pair. It is a single bond pair. Chlorine atoms are sharing 1 pair of electrons. We call it a single bond. Single bond, you can make it as a Lewis, will be like a minus. So this is a single bond, abbreviated with a dash. So it's a minus or a dash. Now oxygen gas. Let's see. Oxygen outside has 2 for 6 electrons. You remember electron configuration of the oxygen, 8 electron, 1s2, 2s2, 2p, 4. So you deal with the 2s2, 2p4 only. 6 electrons in the outer shell. These are the valence electrons. Valence electrons of oxygen, each oxygen atom will be 6. The other one is 6. Let's see how will 2 oxygen form a bond. Look at these electrons. They are unpaired here, unpaired when they are separate. But now one of them will come here, the other one will go there. And now look what will become. Both atoms want to gain 2 electrons. In this case, what they do, they share these 4 electrons. So now we have double bond. They are pair of shared electrons, paired. So 2 pair we have, 1 and 2. And now here, what we have, 6 valence electrons plus 2 will be full octet, and the other one similar. So each atom formed octet rule, octet valence shell, stable by sharing electrons from the other atom. This is 2 bonding pairs, 2 bonding pairs. What they do, double bond. That's it. We achieve double bond. Now, review. Okay. So thank you very much.